Dear colleagues, good morning. My name is Stefan Milanović and I am Master of Science in Mechanical Engineering at the Faculty of Mechanical Engineering here in Belgrade. My mentor, PhD assistant Professor Tamara BAJC, and I have done research in the field of the thermal comfort. In this respect, the title of this work that I will present to you is the thermal comfort impact on occupants' working productivity loss in offices. Thermal comfort and indoor air quality have a great influence on humans' health, especially in indoor spaces. In combination with local thermal discomfort, they have very negative effect on occupants' productivity and concentration. This paper presents the impact of the indoor environment on productivity loss and thermal comfort of persons in real conditions of 2 offices at the Faculty of Mechanical Engineering. The research and measurements were carried out over the 3 periods in the first half of 2018, and they represent 3 scenarios of this study. Throughout the entire research period, 2 persons of different gender were staying in both offices. Also, a very important fact for this research is that offices have completely different orientations. 3 scientific methods were used for analyzing thermal comfort and air quality in offices, and which are experimental, numerical, and statistical methods of research. Before the measurements, it was necessary to analyze the results of the relevant papers related to this topic. The most important conclusions derived from relevant papers are these 5. The allowed higher environmental parameters are still too high for offices in the summer period. The desired temperature is usually lower for 0.5 to 1 degrees Celsius from natural temperature. In offices, there is a very little influence of floor or ceiling temperatures on local thermal comfort. There is a significant cultural impact on the feeling comfortable in the indoors, and the influence of thermal discomfort on working productivity in offices is on average about 10%. An important achievement in the field of thermal comfort is Funger's thermal heat balance model, and it is used in this work. He argued that the human body is aiming the heat equilibrium, where the accumulated amount of heat is equal to the amount of heat transferred to environment. In the Funger system, the PMV and PPD indices are introduced, which can assess the comfort level in the room. Offices are located in Belgrade, and they belong to a climate area that can be described as moderate continental, because climatic conditions are one of the most important factors in the feeling comfortable in indoors. Measurements of the temperature and relative humidity were made during the entire period of the research. Offices have completely, like I said, completely different orientations. Office 1 southwest and Office 2 northeast orientation. And the outer wall of the Office 2 is completely sheltered from direct solar radiation unlike the outer wall of the Office 1. Both offices are supplied with hot water for heating from a two-pipe central heating system, and radiators of similar dimensions are located in parapet under the windows. Of the other mechanical installations in the Office 1, a split cooling system was used when it was needed. Experimental measurements were made to collect data on physical quantities that directly and indirectly influence thermal comfort in offices. The temperature, as well as the relative humidity of the air, was measured at these 4 selected points at 3 heights in both rooms, offices. In order to collect data in different climatic conditions, 3 scenarios have been created. The first scenario is so-called winter scenario. During this period, almost every day there was a need for heating, and the radiator valves with the thermostatic heads were set to a value 5. Second scenario was carried out during the transitional period between winter and spring. Characteristics of this scenario is that the radiator valves and with their thermostatic heads were set to a value 3 when it was need for heating. In the summer scenario, the outdoor air temperature reached 30 degrees Celsius, which caused the need for cooling in Office 1. While in the Office 2, the feeling was more comfortable and there was no need for cooling. The internal unit of the split system in Office 1 was set to a temperature 27 degrees Celsius, and its fan operated in first speed. For the needs of the statistical part of the research, the questionnaire was made in the framework of doctor's dissertation BAJC, and it was adjusted to the research in Office. Using the questionnaire, users' subjective impressions of the level of convenience of different types of comfort on their and their impact on their productivity were recorded. The main objective of collecting and analyzing this data is to determine the relationship between environmental parameters obtained with measurements and CFD simulations and the subjective sense of convenience of persons in offices. Survey of these persons was made every day after experimental measurements. These charts in figure 4 summarize the responses of the thermal comfort of the male on the left side and female person on the right side in Office 1 on the scale of subjective feeling of thermal comfort level. The differences between the impressions of the male and female person about thermal comfort is presented. Since the largest number of responses of the male person was 2, which presents like it was warm in the office, while for the woman person is 0, which presents a neutral impression of the thermal comfort. Similar situations applies to Office 2 between the responses of men and women. But in most cases, the responses between these two offices are shifted to 1 point on a comfort scale, which means that often the comfort level is better in Office 2 than in Office 1. The following two diagrams show the effects of thermal comfort on the work productivity of persons in both offices. The answers of a woman are shown with the red stairs, while the responses of the male are shown as blue. In Office 1, the majority of women's responses to the effect of thermal comfort on productivity are from 1% to 10%, while for the male person this impact is more drastic, in most cases between 21 and 30%. Regarding Office 2, the results of the female person are very similar. It can even be noticed that the effect of thermal comfort on decreasing productivity of female person is even lower than in Office 1. On the other hand, the male person has an even more significant reduction in the effect of thermal comfort on productivity, but in Office 2 this influence is still higher for the male person. Figures 8 and 9 show the impressions of both people on air quality. In offices, the Office 1 diagram shows that the male person is more satisfied with the air quality than the female person, since the majority of the male person's responses had a value 1, which represents good air quality, and the female person is -1, which is a poor quality of air. In Office 2, the differences between the responses of men and women is even more evident. The decrease in productivity due to the impact of the air quality is an average about 10% for both persons in both offices. For numerical part of the research, CFD software Phoenix Flare was used. CFD is a tool for analyzing problems involving fluid flow, heat transfer, or mass transfer. This Phoenix Flare, it is a commercial software used for environmental simulations in buildings, and in this study and research it was used to determine the temperature of air, relative humidity, CO2 concentration, PMV, PPD, and PLUS indices in each point of the office. Design models of both offices are shown in this figure. The following few slides show the results obtained by CFD simulation simultaneously for both offices. Only results were given for a typical day of the first scenario, 5th March, at a height of 0.6 meters for the most important thermal indicators, like PLUS index here, and PMV index, PPD index, and this is a temperature field. Of course, CFD simulations have been done for all 3 scenarios described, and the results are shown in the appendix of my master thesis. By comparing the results of the numerical and statistical part of the research of thermal comfort, it is concluded that the values of the PMV index from numerical part of simulations don't deviate much from the impressions of the users. Even these values often coincide with the median response values. Differences in users' responses about thermal comfort in the same environmental indoors spaces indicate that there is an evident influence of the personal factor, and in this case that personal factor can be characterized by as gender difference. On the other hand, the difference in responses between offices indicates that there is an impact of the most important difference between these two offices, which is their orientations. Regarding air quality, by measuring the concentration of CO2, it was understood that this value never exceeds 1000 ppm in the offices, which is within the limits of satisfaction. From this data and negative users' ratings on air quality, it can be concluded that the threshold of the users is lower than expected. Finally, the two most important conclusions of this study are that the orientation of office can significantly influence on thermal comfort, indicators of thermal comfort, and that the personal factor in the most cases has a greater influence than the parameters of environment, especially on the decrease in productivity of persons. Thank you for your attention.